Hello everyone, this is Spencer from Hydromantis and welcome to the webinar for March. We're going to be talking about GPSX and the Influent Advisor tool and how you can use this custom design tool within our GPSX software to help you sort out your Influent data and get your model set up correctly so that the Influent characterization that you have, the data that you're using and the fractions that you set and so on will be appropriate for the simulation that you're doing. Okay, so my name is Spencer Snolling. I'm VP of Product Development here at Hydromantis and the guy that regularly does the webinars. So I'm glad that you could join us today. So the plan for the talk today is to start out talking about the Influent models that we have in GPSX. Those are the things that help us enter in the data that we have about the flow that's coming into the plant. And I'll talk about why we have so many different ones and why they're important and how to choose the one that you need. And then we'll move on to talking about the Influent Advisor tool that's built into the software and all of its various features. And as we always do, there'll be a desktop demonstration of that. And then I'll talk a little bit about the various Influent characterization issues that you can typically run into when you're setting up your software, when you're setting up your Influent. I am going to touch just a little bit on industrial influence as well. Typically, we stick to talking about municipal stuff, but when it comes to Influent characterization, things can be quite different in the industrial wastewater world. And as always, we'll answer some questions at the end of the webinar. So if you look at your GoToWebinar dashboard, you'll see that there is a questions panel. So if you open that up, you can type in questions there and I will see them here. So as you do that, feel free to type in those as the webinar is proceeding. And usually we'll kind of wait till we get to the end and then I'll stick around and answer a few of those. Okay, so let's talk about Influent Models. So this is a little bit different use of the word model than we would for all of the other unit processes that we would have in GPSX. So when you right click on an Influent object, as you can see here in this slide, if you go to the models menu, you'll open it up and you can see that we actually have 6 different kinds of Influent models that are available there. And actually the input menus that are available for an Influent object are actually a little different than you would find in all the other objects. Influents are treated differently because they're sort of the beginning of the process and they have some special features there. So in the models menu here, you can see that we have several different kinds. The purpose of these things is to calculate and transform the information that you have in the measurements and the concentrations that you have, those composite variables that you've measured like BOD and COD and VSS and TSS and so on. That information from the format that you've collected it in into the format that GPSX needs to be able to use those ASM models. So if you've taken any of our training courses or if you're familiar with the ASM type models that we have, ASM1 and 2D and so on, and of course most people use the Mantis 2 model, that is our in-house model that we've been developing now for, actually over 10 years now. These are the state variables around which we do all of the mass balance and we integrate the concentrations over time. So I won't go through all the details here, but these are, biomass types and we have soluble, inert, and soluble substrate and so on. These are things that you don't directly measure in your Influent. So, but you do have measurements for other things, sort of combining a lot of those things together. So what we need is we need to get from the information you do have to the information that the model needs. And essentially, that's what an Influent model does, is it converts that measurements into the things that the model needs to be able to move forward. So you'll notice that we have several of them. And so here's a little table that describes what they are. The point of having different ones is that we want to be able to give you options to start from different types of data. So you may have BOD data and TKN and total phosphorus, for example, or you may have COD data and some other information. The reason behind these is that we kind of want to have options so that you can match up the data that you have to one of the choices that we have available here. So you can see, of course, they're the BOD-based and COD-based. Those are ones that start with essentially TKN and total phosphorus, and then either the COD or the BOD option. The COD states model, which is actually the default model that will always be there when you drag an Influent object onto the drawing board. And by the way, I should mention that this is for that continuous pipe influent object that I mentioned there, but all of what I'm talking about today also is true for the batch influent, the truck, as well. So the COD states model, basically this is the one that we use the most. It starts with COD, TKN, and actually also for ammonia and soluble and total P. And that's sort of a nice way to get that, and you use a bunch of fractions to define how that goes, and I'm going to show you some demonstration of that shortly. We have a sludge influent object. It's basically one with the default set at really high concentrations, and it's kind of set up as if that was a, thickened sludge or coming from the secondary clarifier or through a thickener. You can adjust the concentrations up and down accordingly. The states model is actually specifying those state variables directly, so there is no translation, so to speak. Mostly this is used in-house by us to develop models, but I know some people who like to have that level of control where to be able to adjust each one of those things individually, so it's there if you like it. And we also have a TSS fractions model where you start with the TSS value and everything gets defined by stoichiometry from there. Okay, so let's move on. Oh, I would mention, by the way, here highlighting that the COD states model is the one that I personally prefer, and I know that most of the people who use GPSX like this. That's why we've made it our default. So I do recommend using COD states most of the time if you can. I know you don't always have COD data. Sometimes you're stuck with BOD and you got to go from there. Okay, so influent characterization, that's basically taking the concentrations and the data that you do have and setting it up and letting all the calculations happen so that the models can have their input. That is actually involves making some assumptions or making some adjustments for the information that you don't have. So like, what is the soluble inert fraction of my COD? So influent characterization is really important because basically it drives the rest of the model. So if I have a really large inert fraction in my influent, that's going to have a big effect on my mixed liquor downstream and so on. It's really the key to doing the calibration. So you can always calibrate some of the biological or settling parameters downstream, but often it's really important to make sure you get your influent set up correctly first. And a really poor influent characterization will leave you really struggling to make anything match and kind of defeats the purpose of using these types of sophisticated models. All right. So basically the Influent Advisor tool has been designed to be able to do these calculations that would normally be done as part of the regular model as it integrates along and runs dynamically and so on. And what we're doing is we're doing that in the interface, in the menu itself, before we actually get to running simulations, because we want you to be able to interactively see and check the data that you're using automatically. So we used to have a spreadsheet at one time that existed outside of GPSX that did this. And quite a few years ago, I think it was GPSX version 6, it took what was the functionality of that spreadsheet and built it right into the software. So this is now a special interactive menu that actually checks the values and displays information and does the calculations of the influent models right in the menu. It makes it much easier to see and check the data as you're entering it, and once you've kind of got all the information in and you can take a look around. It also has some features, which I'll show you in a moment, to check the dependency of the calculations. If I identify that there's something that looks off, I can click on that value and find out how it was calculated. And it's really good to be able to have all of that information shown sort of neatly in one place. So it's kind of a big, large menu that has a lot of information in it. But once you kind of become familiar with what's there, you'll be able to use it nicely. So first of all, how do we get to it? So in the influent model, influent object, if you right click and go to the composition menu, meaning what are my calculations or concentrations and so on, then go to the Influent Characterization menu. When you pop that up, you will get something that's different than all of the other menus in GPSX. You will get this thing. And so it's basically 3 columns of information, and it serves both as the input menu where you enter in the numbers that you do know, and as well an interactive tool that allows you to see the calculations as they will happen when you're running your simulations. So first of all, at the top of the left-hand column is where you're going to input the concentrations that you know. So this is the typically those first sort of 10 to 15 items at the top of this menu are the things that you're most likely to have information for. So you're probably going to have a COD or a BOD number and total phosphorus and maybe ammonia and that sort of thing. You might have a VSS to TSS ratio, that kind of stuff. Those numbers are the ones that you're most likely to have sort of hard measured values for. So you enter those numbers in here. The next step farther down that menu is actually the stoichiometry. And depending on which of the models that you've chosen, this could be a little bit shorter or longer. I'm showing you the default COD states menu here. And you will find things that you probably don't have information for. So this is, for example, it's showing there, right here, soluble inert fraction of total COD. So you may or may not know that, but you may be able to easily make adjustments here to that value in order to calibrate your model when you get to that point down the road. One of the most important things to know about calibrating your model is that particulate inert fraction of the COD. How much of that stuff is not going to be broken down or not very easily broken down in the system. And so it's going to have a big effect on your mixed liquor. So that is something that you can adjust here. So when you entered in all of that information, and there's quite a few sort of extra things down below this menu here, it kind of goes on farther down. A lot of the information that exists farther down in the menu is certainly things you probably don't have information for, like what is the individual biomass concentrations and the concentrations of the precipitates. Things that are highly likely to be zero, but you probably don't have a measurement for anyway. So we've got some good defaults in there for you. Then these numbers in the middle and right-hand columns will be calculated for you. So here, this is the state variable concentrations that the Influent models are going to calculate for you. So in some cases, they are directly taken from the information that you had. Most likely, they are calculated via a couple of simple algebraic equations. Then the last column is the composite variable calculations, the entire set of them that we would normally calculate, as we do in every connection point throughout the entire model. And you can browse through here to see. So you would enter in, so this is going to be a repeat of some of the information you started with. So you're going to enter in your total COD and your total TKN. And then once you've done all those calculations, you can now see how the model is going to interpret all of that other information that you didn't have measurements for. So you can see here, this is what we think the total BOD is going to be, and the VFAs, and particulate and organic carbon, and all of that kind of stuff. And so you can make adjustments to the stoichiometry over here in order to dial this in. So those are sort of the essence. Your input is on the left, and the middle and right are the outputs that the thing is calculating for you. So as I mentioned before, this is fairly interactive kind of tool. So we've designed it such that you can see down here at the bottom, if you scroll the way down to the bottom in the two right-hand columns, the equations of how we calculated these. So if I click on total carbon here, for example, it'll pop up the menu that the equation that we're using here to calculate that. And in fact, it will even highlight the values that are used in that equation. So we can see here that total carbon is actually the sum of total inorganic and total organic carbon. And so it's fairly straightforward calculation. If you click on some of the other ones, you'll see sometimes quite a lot of numbers involved and quite detailed calculations there. But if you ever need to know how these things are related together, that's how that works. One of the other things that I find very handy, particularly when we're doing modeling of BNR systems, is to be able to have a number of sort of standard types of ratios calculated for you if you don't already have that handy. So things like the nitrogen to COD ratios and phosphorus to COD ratios, VSS to TSS, and so on. And you can see all of those things are calculated here. So as you update your numbers, these numbers automatically get updated as well. Lastly, I'll mention that in version 8, the most recent version of GPSX, the pH and alkalinity is now part of Influent Advisor. Up until recently, it had its own separate menu, and so we've now combined all of that in, and we're doing those calculations accordingly, although I will remind you that in order to be able to there's sort of two different ways you can deal with pH in GPSX. You can either set it directly, so you might like to do that in the Influent, or you can actually estimate what that would be, and that's a global setting within GPSX. But if you're going to be setting it directly in Influent Advisor here, you can do that. And that's the way that like almost everybody does it, is we're going to set it directly here as part of that menu. Okay, so let's hop over to my desktop now. And so you can see here, this is GPSX version 8.01, and I've got an Influent object on the screen. And as I mentioned before, there's all the different Influent models that you can work from. I'm going to go right into Influent Advisor here and just show you some of the features, software features here, so you can see all of the new things that we've added. There's a few things that are new this year. So basically, as I mentioned before, this is the left-hand side. This is the input here. I can come in, I can type in new values, for example. You can see here that when I, just like all of our other menus, when I enter in a number that's different than the default, it highlights that so you can easily see. That's just sort of standard GPSX functionality. One of the things that happened sort of as we've developed up more sophisticated models over the years now, there's more state variables, there's more composite variable calculations happening. What we've noticed is these menus have become quite long and you have to scroll up and down a lot. So we sort of broke the input and output into separate windows. So I can scroll this one up and down separately from the output windows over here. So that's sort of a new feature that makes it handy such that I can make these adjustments and still be able to see these things at the bottom of the other menu there. Also, due to the fact that we have like such a large amount of information there to be able to handle, we've taken what are the groupings of the various variables that are there, and we've actually now made it so you can collapse a few away. If I don't really need to see all those individual biomass, which probably are all going to be 0 anyway, I can just collapse that away just like that. And so now I can see that some of the other information, all of these precipitates are available here to be viewed as well. Okay, so how would I click on a variable just to see what's going on? So I can click on something here. I think I clicked on some of the nitrogen variables, for example. I can see the total TKN here is soluble TKN. Those are other nitrogen variables here. We add soluble and particulate to get total. I can calculate soluble nitrogen here, and I can sort of trace back all the way through the Influent Advisor interactively here to see which are the parameters that are being used to be able to calculate these numbers here. So those equations are available for you to be able to sort of get a flavor for how we put all those things together. I find it helpful if one of these things turns up and is flagged as a problem, then I can sort of trace back which parameters I should be adjusting. Right. Okay, so that's the other feature that is probably the most useful one, or one of the most useful ones that we have built into the software here, is the fact that I can see immediately when there is a problem. So let's, for example here, take a look at the situation where my TKN is actually less than the ammonia. That would, of course, be, doesn't make any sense, because ammonia plus other things are equal to TKN. So if this number was something really small, say like 20, because now that's less than 25, I can see here immediately that we can see that there's now some things that are highlighted in red. So I'm going to open up this nitrogen variables here. We can see this is negative, this is a negative number. This is telling us that we have a problem with the data that we have. It's calculating a number and it's coming out as negative. So really what's happening here is that when we're calculating all of these other things, we're of course trying to mass balance the COD and then the nitrogen and then the phosphorus and so on. And quite frequently we have to sort of say, okay, we've assigned a certain amount of nitrogen to all the places that are known, and then everything else goes into, in this case, the nitrogen and the slowly biodegradable substrate. Well, we've now got something that doesn't make any sense. So we have a negative number left over. So we need to address this. And so if I click on this, we can see it's now highlighting the things that are used. And of course, it is highlighting that number that was the one that I changed. That was the problem. So you can click on these numbers to reconcile those, and we'll put this back up to a number that makes a bit more sense. And we'll see the red numbers go away. Right. Okay. So that's sort of the basic features here. You can go through and you can enter all of these numbers and calculate that, identify where you have some problems, and then use the sort of dependency tracing of understanding which calculations you have to change in order to solve that. Okay, so there are a number of other features that are built into this menu as well. And so down here, some of these have been around a while and some are new. So let's just run through those as well. First of all, you'll notice that we have basically two sets of default values here in this left-hand column. One of them is for raw influent and one of them is for primary effluent. So depending on which set that I've picked from, we'll automatically change up and set these for you. If I flip over to the primary effluent numbers, you can see it changes some of the concentrations, and importantly, it changes a lot of the fractions here. So we can see that we may have increased the fraction of the readily biodegradable substrate fraction of the COD, meaning that there's less particulate after we go through the primary clarifier. So these values are ones that we've worked over some time to calibrate and get our models works nicely with these values. And so those are defaults that you can pick up and use as you need. Okay, I'm going to go back to the raw ones just at the default here. Right. Okay, so this button down here in the lower left-hand corner, which is actually available now from several different places in GPSX, but we put it on the Influent model as well. If I click on that, that's part of the Site Properties menu. So this is a value that is going to be used that is the same across the entire wastewater treatment facility. And in this case, under this Influent Characterization tab, we have a couple of ratios that we assume remain constant all the way through the plant. And in this case, the particulate COD to VSS ratio of the particulate and inert substrate. These are numbers that are actually used in all of these calculations here. We wanted to make sure that everybody could see that those are nicely available from this value here, from this menu here. So, all right. There's next to that is our new notes button. So you may have seen on many of our other menus that you can click on this and type in some notes here, and that text is saved along with your GPSX model. And it actually gets output to the Excel report, and it actually becomes part of the new Word report that we have created as well. And so those things are available. You can add those here. We didn't used to have any notes on this page, but that's a new thing. Okay, I'm going to jump over this one for a minute and come back to this Excel. We can take all of this information that is here and immediately generate an Excel spreadsheet. So we can do that. I'm going to open up that new Excel spreadsheet, and you can see here, basically it's just something that you could cut and paste these tables into other reports or do whatever you like with it, but it's a nice way to sort of, click of a button, I can get all that information out into a nice format. Okay, and lastly is this tool right here, this dynamic data validation tool. And this is actually new in version 8 as well. And this is something that is actually really quite useful if you do a lot of dynamic simulations. So everything that I've described here in terms of highlighting where there's a problem and it shows up in red and so on is actually just for one set of numbers that you have entered. However, what do you do if you're in a situation where I'm going to be reading in those numbers? I may have, 100 sets of numbers. I don't want to obviously have to sit down and type all 100 sets of these every data point into Influent Advisor to check it all. And so that's what this button does for you. So if I go down here to the lower left-hand corner, I click on Dynamic Data Validation. And what you can do is have GPSX load in your dynamic data that you're going to be reading and scan through it and do Influent Advisor calculations all the way through on every row of your file, and then highlight where there is a problem. So for example, I specify the input file. So automatically it's going to show me here the ones that are available for me to take a look at. So this is my input file that I had set up for this demonstration. And then I'm going to generate an output file as well. So this is going to have the results of this data validation check. And then I click on validate data. So what it's going to do is it's going to go through every row of my sheet, and it's going to check and see how the calculations worked out. Now, it's quite a lot of calculations, so it's going to take a couple of seconds here. I'm going to pause and have a drink of my coffee. Okay, so now we can open that up. And now this is basically the results of taking all of the inputs and generating all of the outputs in the Influent Advisor sheet and calculating that and then flagging where there is a problem. So first of all, these first few columns here are essentially all of the state variables that get generated from the inputs that were in that Excel spreadsheet. And we go all the way over here and then we calculate all of the composite variables as well. So this is sort of just a raw data dump. These are all the things that we calculate every time step as we go through that process. So if I start to slide down, I should find, yeah, right here, places where at least some of the time there was an issue. So we can see here that this is actually a negative number. Let's see, what state variable is that? That is XPS. So that is one of the phosphorus variables. That is the phosphorus associated with or tied up in that particulate substrate. And this is a problem. So we know that this particular this particular row of data needs some adjustment in some way in order to fix that up. And so we can see it happens here for a period of a day, then the rest of the data seems to be fine. I know that if I slide farther down here, I can also see a couple of other examples. There's more phosphorus problems. This one is a nitrogen problem. So it's a nice tool that kind of slides through, flags parts of your dynamic data set, and tells you, here's something that you need to take a closer look at. All right. Okay, so I'm going to close this and close this and go back to my slides. Okay, so I'm just going to wind up here with a couple of other discussions here about the different Influent characterization issues that you should be aware of. So when you're doing a calibration of a model, even a simple steady state calibration of a regular activated sludge model, you've got so many different parameters that you could deal with in terms of doing, making changes to try and match the model results to the data that you have that's measured from the plant. So you're going to try and you're going to match the effluent ammonia and you're going to try to match the mixed liquor and so on. Our experience and the way that we teach people to calibrate the models is that we don't want to make a lot of changes to the biological parameters that are there. Most of the time, really, you're spending a lot of time characterizing your influent, getting it so that you have the COD into the right balance of soluble and particulate and inert and biodegradable. And so you don't really need to do a lot of changes of those default growth rates and half saturation coefficients most of the time if you've got a good characterization of your influent. Often, if you find that I have to really go in there and adjust some oxygen half saturation coefficient or growth rate or something, it's probably because you don't really have enough information in your influent. So a lot of the time we tell people, if you have limited budget to spend on getting data for your model, make sure you spend as much of it as you can on the influent, since it's one of the most important ones. So you're going to have some influent data that you have, and often you'll end up with a long dynamic data set. And what you're looking for when you're doing a calibration is a stable time period, and sometimes that can be kind of tricky. And by stable, we don't mean necessarily non-changing or completely flat. What we're talking about is where you have stable performance of your plant. You're still going to have your daily diurnal patterns and potentially changes over the season and so on, but you're looking for finding a period where the plant has typical behavior. And then during that time, you may want to sort of find a good value to use and enter into, for flow and concentrations, enter into your Influent Advisor spreadsheet. And typically, you would take an average, but you want to make sure that that average is representative of the period where the plant was under that typical behavior. Not when there was an upset and not when you had a bunch of things out of service. Try to keep that in mind when you're taking your periods and doing averages or median values to try and find a good way to represent the average loading to the plant. So don't forget, you'll be taking an average of flow and an average of a concentration and multiplying those together. So make sure that that number you come up with at the end is a representative average loading to the plant. So when you're doing that, you of course want to scan your data and understand what's happening there. Keeping in mind there's always lots of different kinds of error sources in the data that you have. So just like any of the data that you use in the models, it's important to make sure that you remove the outliers and scan and get rid of any missing or bad data, or as I like to call it, stuck data, where sometimes I saw this a couple times recently, you'll see a value repeated over and over and over again, for many rows of your spreadsheet because a sensor went offline or something and just kept reporting back whatever was the last thing that it knew. That kind of stuff needs to be flagged and identified. So often you'll end up with sometimes, conflicting information. And so it's up to you to sort of evaluate the information you have and make sure that you are using reasonable results when you're doing that. Right. So as we mentioned, the best way to do that and to reconcile that data, make sure it's going to work for the model, is to put them into Influent Advisor, use the GPSX defaults for information that you don't have, and then look for those flag values. So the ones that we showed you earlier, things that are going to be negative, make sure that ultimately you're matching both the COD and BOD numbers if you have them, and really check those concentrations of those state variables there to make sure there's no negative ones and that it sort of makes sense for what you have. So often, once you've done that, then you would run a steady state simulation, and you may need to then go back and make further adjustments to calibrate the model. Make sure you get the right amount of particulate inert material coming into the plant. That's going to accumulate in your mixed liquor. And by adjusting the influent, you can actually adjust the entire performance of the system. This is often a very iterative approach, meaning that you're going to make some changes, then you got to go back and make sure that nothing got tripped up and become negative, inadvertently made something else negative, or pushed you off of some other value that you had measured. So sometimes it's you got to go around and do 2-3 iterations to make sure everything is solid. So this slide is actually something from one of our regular training sessions that talks about what you would expect to see in terms of the breakdown of the COD in your Influent characterization. And these numbers here, the fact, say, for example, that we would expect for a regular municipal wastewater that 20% of that influent COD would be solid, would be readily biodegradable substrate, 13% would be particulate inert, and much of the rest of it, or sorry, soluble inert would be 5%, and much of the rest of it would be 60% or more would be the slowly biodegradable substrate. These are kind of ranges that are typical values for regular municipal wastewater, and you can see a majority of that is going to be in the slowly biodegradable substrate format there. And so these are some numbers that you could typically take a look at. These numbers here are what we've set up our GPSX Influent models so that it matches this number. So you'll be starting from here and then making adjustments probably within these ranges. Okay, so that's for regular municipal domestic wastewater. We also do quite a bit of industrial modeling here at Hydromantis, and I know many of our clients do as well. I just thought I'd mention very quickly that the industrial wastewater characterization, it's very much done the same way. You may find that you have to make changes farther away from the default values because industrial wastewater really does vary quite widely from one industry to the next. So you certainly would have a much different influence if you took wastewater from, a dairy or a winery or, a food processing facility, that kind of thing, versus pulp and paper waste or a mining waste, that kind of thing. So those kinds of things are going to be specific to each industry, and even within one industry, it varies quite a bit from plant to plant, and even within a plant from one product to the other. I've worked on a couple of food processing places where the wastewater that was generated and sent out for treatment was very dependent on what it was they were making. So their fish stick production produced a certain kind of waste that was very much different than when they were making, other kinds of French fries and other things. So these are all very interesting aspects of industrial wastewater that it varies quite a bit. Often they're very high concentrations. So we did a project a few years ago with winery waste that was over 250,000 milligrams per liter of COD. So They can either be very nutrient rich, meaning you got lots and lots of nutrients and no COD, or nutrient deficient, where you got lots of COD and no nutrients. So you really need to potentially change some of those default nitrogen fractions and phosphorus fractions in Influent Advisor in order to get everything nicely cleaned up. And what we often tell people is, if you have the opportunity to work on one of these plants, it's really worked well for us to sort of have a characterization for each different product that's being produced. So as I mentioned earlier, a certain kind of food product is going to give you a certain kind of wastewater, that sort of thing. Okay, so just to wind things up here, how am I doing for time? Oh, I'm over by a few minutes. There are certainly many different model options for GPSX, and we advise you to sort of choose the Influent model that works for the data that you have. But we all find that the COD states model, which is our default, is the one that often works the best. The Influent characterization, as I've emphasized, is actually very important and a very key thing to doing a good model calibration. And that Influent Advisor tool is designed to help you do that to the best of your abilities. So it's there to help you visualize data issues, track down which variables need to be adjusted. And if you have any problems, it'll highlight them and make them easy to identify as much as possible.